All right, so we are going to go through this review. If you did not understand some questions, we'll do them again. It says, which explicit formula is represented by the graph? Our first thing is to write our points. 1, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, negative 3. So our first point is 1, negative 1. Then we have 2, 1. Whoop. Then we have 3, 3, 3. Then we have 4, 5. And we could do all of them, but let's just do the first few. So what we're going to do is in Desmos, we are going to put the points. 1, comma, negative 1, parentheses. Then we have this green point that pops up. That's good. Then we want 2, comma, 1. Then the purple point pops up. That's good. And then 3, comma, 3. And we can just leave those 3. So then I can actually graph. Actually, I'm not sure how she did it. Oh, A sub n equals 8 minus 2, parentheses, n minus 1. And that line does not go through the points. I need it to go through these 3 points, all 3 of them. So A does not go through the points. So let's try B. A sub n equals negative 1 plus 2, parentheses, n minus 1. And that one goes through all 3 points. So this is good. This is what I want. So B would be my answer. Okay, so now let's try the next one. That's the first kind of example. Our next one is, which explicit formula is represented by the graph? So I have these. Let's see, can I graph these in here? We're just going to graph them and see which one kind of makes this J shape. So we have G of n equals negative 4, negative 4. Up here, then put parentheses x, or, oh, my bad, n minus 1. Nothing happens, so I'm assuming that graph doesn't pop up. So I'm going to put an x here. Then let's try G of n equals 4 to the power of n minus 1. And that one does pop up. So maybe this is my answer, but let's try the next ones. G sub n equals 1 to the power of n minus 1. And that's just a straight line. So we know that cannot be my answer. Now let's check D. G sub n equals negative 1 n minus 1. And we see nothing happens again. So B would be my answer. And if we go to this one's a good one. It says, which representation shows the first five terms of the sequence given the recursive formula? So we have the formula, and we have our A1. I know I'm looking for the first 5 terms. So we have A1, A2, A3, A4, A5. We have that. Our A1 is 2. So A1 is 2. That's there. Our pattern is plus 7. So you have plus 7. 7 plus 2 is 9. Then you have plus 7. 7 plus 9, 16. Then you have plus 7 again. Then you have 22? No. You have 16 plus 7, which is 23. And then you have 23 plus 7, which is 30. So what we're doing is we are looking for these numbers in our answers. So AN, so right here, right here, right here, and then these points. So the one that matches the best is D. That's how you would do them. For the next one, a sequence can be generated by using G of n equals R times G sub n minus 1. Remember, when we see G, we should think G, oh my God, geometric. And they gave us our G of 1, which is 3. G of 1 is 3. And our pattern is 6. And since it's geometric, we are multiplying. Multiply. So, and n is a whole number greater than 1. What are the first 4 terms in the sequence? So I'm doing G of 1, G of 2, G of 3, and G of 4. I started with 3, and I know I'm multiplying by 6. So 3 times 6 is 18. Then 18 times 6 is 108. And then 108 times 6 is 648. So, again, we are looking for... Nope, wrong pen. We are looking for these numbers in our answer, and the best one to do is this one. What we could have also done, and a very good point is G1 is 3. Any answer that does not start with 3 has to be eliminated. You do not want them. They cannot be the answer. So let's keep going. You have, in the sequence of numbers, G of 3 equals 36, G of 4 equals 72, G of 5 equals 144, G of 6 equals 288. Based on the information, which equation can be used to find the nth term in the sequence? So, I know, I always start with G of 1. We don't know what that is. I have G of 2. I don't know what that is because they start with G of 3. G of 3 is 36. G of 4 is 72. G of 5 is 144. And G of 6 is 288. So I know that my formula is G of n equals A1, no, my bad, G1 times Rn minus 1. A super important thing to notice is it's n minus 1. Look at the n's. Which ones can we eliminate? Correct. Anything that's plus 1, get rid of it. We don't need it. My other thing is that I have G of 1. G of 1, I don't know what it is, but I do know that G of 3 is 36, meaning it cannot be 36 because G of 1 cannot be 36. So I know I can eliminate this. That means my answer has to be C. Yep. Okay. That was one question 5, 6. This is the same kind of setup, so I'm not going to do the example, but it's very similar to the one I just did. The next one is, consider the sequence shown. Write an explicit formula and a recursive formula. First, I have to determine, is this arithmetic or geometric? So looking at the first one, I have 1, 2, 3, 3. 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5, 6, 7, 7. So my A1 is 3, my A2 is 5, and my A3 is 7. And in this situation, we have 3 to 5, which is plus 2, and then 5 to 7, which is plus 2, which means this would be arithmetic. So what I need to do is look at the posters that we have in the class, and for explicit, it's AN equals A1 plus D n minus 1. And for recursive, it's AN equals AN minus 1 plus D. Remember, the only things that we are changing are the D, and then in the explicit formula, the A1. The A1. So our A1, again, A1, you already wrote it, it's 3. So we have AN equals 3. Then our pattern, our D, is going to be the plus 2. And then we just copy n minus 1. N minus 1. That's my answer for this one. The next one, same thing. We have an equals an minus 1, and then our d is plus 2. That's my answer. You are just replacing the values. That's it. Okay? So, going on. Oh, this is great. It says, nope, where is it? A sequence can be generated by using an plus 1 equals 0.75 plus an, where a1 equals 9 and n is a whole number greater than 1. What are the first 5 terms in the sequence? So I know I'm looking for the first 5 terms. So that's a1, a2, a3, a4, a5. So let's make our little thing. And then we know they gave us a1 equals 9, which is great. Perfect. a1 is 9. Then if I look at my formula right here, it's telling me, oh, we're adding 0.75 to each one. So add 0.75. That's all we're doing is finding the equation and adding it. So 9 plus 0.75 is 9.75. Then 9.75 plus 0.75 would be, 10.5, because we're just adding 0.75. Then 10.75 plus 0.75 is 11.25. Then if you add 0.25 or 0.75 again, you get 12. So when you're doing this, you have to list them. You're going to list these numbers. So you have 9, 9.75, 10.5, 11.25, and then you have 12. This would be your answer, a list of terms. So then, this is very similar, so I'm not going to do it. You should practice on your own. This is the same thing, very similar to what we just did. Same thing to what we just did, same thing to what we just did. They're all practicing plugging in the terms. These are different. So it says, determine the 60th term in the sequence defined by an equals negative 14 plus 2, parentheses n minus 1. So right here, it says 60th term, 60th term. That means my n is going to be 60. So you have a, and anywhere, we have n equals negative 14 plus 2, n minus 1. Anywhere I see an n, I'm going to replace it with 60. So I'm going to erase my little n's, and I'm going to write 60, 60. And then what we do is we just plug this into the calculator. So we have negative 14 plus 2, parentheses, 60 minus 1. And that gives me a 60 equals 104. That would be your answer. So you're just plugging in the 60, plugging in the number they gave you, and that's it. Same thing here. Determine the 6th term in the sequence defined by xn equals 15 times, this is a times, or multiplication, 1 over 5. So I have xn equals 15 multiplied by 1 over 5 n minus 1. So in this situation, our n is going to be 6. So we're going to erase the n and put 6. 6. And then I plug this into the calculator. This is where you have to be careful because I'm going to show you. 15 times 1 over 5. You do the little divide here. 1 over 5. Little bitty number, 6 minus 1. Do you see how this minus 1 became big? That means it's going to be wrong. It's wrong. So you have to make sure the minus 1 is in the top, and you have to use parentheses to do so. So your x to the 6th is 0 sub 6. My bad. 0, 0, 4, 8. This would be your answer. Okay? So it says, for the sequence, write an explicit and recursive formula. So you have to write both. So you have it's probably a little bit easier to make a table. So let's make a table up here. A1 is 15.3. A2 is 11.3. A3 is 7.4. A4 is 3.3. And then A5 is negative 1.3. And if you notice, we are actually subtracting 4 each time. Subtracting 4, subtracting 4. And then that is our pattern each time, subtracting 4. So this is an arithmetic. So for the explicit formula, explicit, we have an equals a1 plus dn minus 1. For my recursive, you have an equals an minus 1 plus d. So remember, my a1 is 15.3. So we're going to put 15.3 right here where we see a1. Erase that, put 15.3. My d is going to be that minus 4. So get rid of the plus. It has to be minus 4. That's my answer. Same thing down here. We're just replacing this d with minus 4. Minus 4. That's your answer. Okay. Just gonna skip that. So this one, a sequence can be generated by using b of n. Oh, we've already done one like this. We've done this. Oh, okay. This one's a good one. This one's a good one. So it says, what is the 33rd term? So we're looking for A33, question mark, of the sequence an equals an minus 1 minus 14 if the 31st term. So I have A33, A32, A31. That's 31st is 55.25. So I don't know A32 or A33, but I do know my pattern, which is minus 14. Minus 14. So I'm going to take 55.25 and minus 14. So you can do it in Desmos. I haven't been showing y'all the math. My bad. 55.25 minus 14, which is, we're going to take this off. This is 41.25. And then you do it again. 41.25 minus 14 again. And that should give you 27.25. So A33 is equal to 27.25. You just kind of got to work backwards from the question, from this, what they give you. You got to look. So then the next one, we just did something very similar to this. Do the same method. And oh, that's it. That's the review. So if you have any questions, let me know. But please practice the review at home. Have a great day. See y'all tomorrow.